So as you can see, that's live coding, server as a function with httpk. Live coding means that there won't be too many slides. And server as a function means, well, it's like the whole term comes from this paper. You can find it online, and it's all about Scala, Finnegan, and it has two main concepts, services and filters, which I'll explain using httpk, which is like a library or a toolkit for Kotlin, which makes it easier to do server as a function. So that's a httpk website. And to illustrate all of these things, I'll use a simple demo introduction to httpk, writing a board for tic-tac-toe game, also known as noughts and crosses. So overall, the design will be, we'll have two components, front and back end. So there is a, let's say, get request from browser, then it becomes get post to the backend. Backend sends back some JSON, and then it's rendered as HTML and sent back to the browser. And to do this, I'll use IntelliJ and Kotlin. And that's the intro. Switch to IntelliJ IDEA, which is in presentation mode. And I have here hello world. So if I run it, it prints hello world. First off, let's do like an advanced hello world in httpk. So the most fundamental concept in httpk is an HTTP handler, which is a function which takes a request and returns a response, where both response and request are immutable objects. So here we can say hello world again, and the request, we can specify type explicit. So this is request to response. We can go to the source code and we can see that HTTP handler really is just a type alias. So it's really just a function from one immutable object to another. Obviously, because it's just a lambda in Kotlin, we cannot run this. So we can ask httpk to plug it into a server. Here I'll use httpk integration with Apache server. And what we're saying here, httpk, can you like plug it into Apache server components and then start it? So if I run this now, we should see that the program doesn't terminate because there is a server waiting for requests. And I can go to command line and run a curl to localhost 8080. So we get printed out that there was a request from curl, and then there was a response from Apache HTTP core, and it says hello world. So that actually works. It's a real web app. But it would be nice, though, to do the same thing from Kotlin. And we can do it in HTTPK using HTTP clients, which is also HTTP handler. Here, I'm going to use integration with a KHTTP library. So HTTPK doesn't reinvent the wheel. It integrates with different servers and clients. So in this case, I'm using KHTTP, and we can just pass a GET request to the same URL we had on command line. If I do this, we get back a response, which we can just print. And the interesting thing here, so let's see if it works. Yeah, get back hello. And that's pretty much the same output as we've seen on command line. And the interesting thing here, and pretty much the most important thing of this whole talk, is that both server and client, they have exactly the same type signature. So they're both HTTP handlers. So they both take immutable request objects, they're identical, and they both return a response. So you can see these are the same types. In a way, we could always just replace HTTP client with HTTP handler, and then, you know, we doing it all in memory. So that's the main thing. Also, like, so that's like the basic hello world. If we want it to be more advanced, we probably want a better server, because right now it always just says hello. We need some routing. And if we do /foo, it probably should be for. And to do some routing, there is a built-in function HTPK called routes. It has a little DSL. So let's say we want to bind hello to bind get to, and then I paste the same lambda that we had. So if I run this now, it should print 404 because we don't have binding for foo. So it takes a little while for Kotlin to compile. And it's still running. Yeah, finally 404. Yeah, so this worked. The other thing which we could do is advanced hello world to maybe pass some arguments. So we could say hello, and then we can pass a name, like a greeting really, and say Brighton, for example. So here we can do request, And request, it's an immutable object that has some convenient functions in Httpk. So we can extract a query called name, and this is going to be a name. So we can pass the name here. So that should now work and basically print the name. So that's a demo how you can extract simple queries using the small DSL http4k provides. So it should hopefully say hello Brighton this time. So it works. Probably need a comma also after hello. And there is also a question of what happens if we forget specify name. And the answer is that it will be hello now, not ideal, because this whole request is a nullable string. There is an obvious idiomatic Kotlin way to do this. Say if it's now, say name is required, and it will throw an exception. If we do this, it's interesting what's going to happen, right? And if we actually looked at it, so we do get 500 back. And the stack trace. So that's a bit weird because we're definitely not doing it in our Lambda. Maybe Roots is doing something, but actually I think it's a http4k integration is doing it for us, like this handler of last resort. Ideally, we should be handling our own errors. And at this point, we can introduce the second most important concept in Httpk called filter, which is a function which takes a handler and returns a handler. So that's the simplest filter you can write, identity function. Again, I'll jump to the source code just to show that filter is just an interface which implements a function type, which takes a handler and returns a handler. If you forget that it's an interface, it really is just, again, a function which takes a handler and returns a handler. So this can look a bit convoluted. So this is definitely useless. Let's introduce a wrapper handler, which is going to be a handler which takes a request, and then it passes this request to the original handler, and then we return wrapper handler. This is still not doing anything, but now we can, for example, do try catch, and if we have an exception, we can return a response saying I'm a teapot. So that's not a serious filter, just catching all exceptions. And then we can plug this filter in our roots and say that's a filter. Probably should call it catch-all. So if I run the code now, we should get I'm a teapot status because this handler is basically, this is roots function. It will be wrapped in this. It will be called over here and then exception will be caught. So we are getting I'm a teapot now. So that's the handler. There are a few built-in handlers in Httpk. So there is this object debugging filters, and we can get print request and response filter, and we can chain it with the filter we had. So what we get back is that filters, even though the type is just a singular filter, because its function composition is like two functions wrapping each other, higher order functions. So this is actually plural. So if we plug this in, we should see that we get in all requests and responses printed out in the console. So it can be useful for debugging purposes. So you can see that's our get request going out from HTTP, that's our response, and then we print it again on the teapot. So this is the advanced hello build. And to be fair, just let's do some cleanup. This catch-all, there is already a kind of filter in Httpk. Shouldn't really do it ourselves, this kind of thing. But I was just showing that it's not that hard. Then we don't need these clients really for now. Then filters, it's kind of one line, I'll inline that. And then these whole roots, we could extract into a function and I'll call it new backend. So this is literally the example of the whole server is represented as a function. So that's what it really means. That's why I didn't want to show slides. It's like easy in the code. This is really just a function. Now, main function is quite simple. It's just that, and that's a new backend. So before doing more functionality, I'll write tests first, at least some tests. And I'll create backend test class. So the first thing I could think of was a state of an empty game. And here we can just create backend just by calling function because that's all it is. So we don't need any dependency injection or anything complicated, just call a function. And here again, because our server is a function, we just, well, this is, to be clear, this is an overloaded invoke, right? So we just call in a function, passing it a request object. And here, what we want is something like a game, right? And then we will expect the response to be okay. now created as an extension function on response, we can say that response status should equal OK. And then we can return response. So here we get back the response object. And we can do, on the response, there is a helper function body string, which gets us the body of the response. And we want it to be some JSON. I don't want to specify it right now. It will be a bit like approval testing all the way. So I'm running the test. So now it fails with, on this line 10, saying it was 404. And that makes sense because this is hello, not game. So let's fix that. Also, I'll just return a K for now, maybe with body, some ... And we are not using request. So I ran the test again. So hopefully now it fails on line 11. So we kind of made some progress. So yeah, we did. And here we want to return JSON of the game, right? So we need some kind of game object and maybe can convert it to stream. This will be a bit of typing now. So the game I'll represent as a data class, which will be kind of functional design because it will be an immutable game with list of moves where each move is also data class, which is represented as X and Y between 0 and 2 on 3x3 grid. And there will be a player who made the move where player is an enum of X and O. So that's the kind of design. So obviously when we make moves, we will need to create a new instance of the game and so on. So like we still get failure, but now we see that expected some JSON, but was game to stream. And we could just write an extension function called to JSON and do conversion to JSON in any way that we want. But there is a bit more idiomatic way for Httpk, which is to use lenses, which I'll explain in a second. But to emphasize, you don't have to use lenses. You can do like custom conversion to JSON. But doing it with lenses, we can say auto body of game to lens. And here I'm going to cheat a bit because there is a long-standing issue with Kotlin not showing imports for some functions on objects. So I had to paste it from a secret place. But what it means is that there is a module of Httpk which integrates with Moshi, and there is this function which creates a lens, body lens. So it's bidirectional body lens. That's what it is. And without making it too complex, there are different ways to think about lenses, but in a simple way, you can think it's just a getter and setter, and it knows how to get a body out of request, and it knows how to set body into response. So we want here setter functionality, which is called inject, and we're injecting a game into response with status OK, and that's all we want. This lens, it will be because it comes from Moshi, it will use Moshi to serialize game into JSON, and then it will set this JSON on the body of the response. So now we see that it fails with this kind of error, which looks reasonable to me. I'll paste it back. And now we should have a test that passes. So this worked, and let's move to the next test, which will be players take turns on each move. So I'll copy this bit because it will be kind of similar, and I'll paste it some JSON. So what we want is to make some moves in the game, basically make a few more requests to the backend, which is going to be post. And then I'll specify maybe it's like x1 and maybe 0 and y1. That's right. Maybe a couple more moves like this. And then we look at the state of the game. So the backend will decide who's the next player who made the move. So really like not a game, maybe it should be refactored to call board. So don't pay attention to this, please. So now like the first failure in line 15, which is saying method not allowed. This is because we have binding to game, but this is like a binding to get, and we can have binding to post. Also, just to mention, there's like these DSLs quite simple. So obviously this is like an infix function in Kotlin 2 as well. It's an infix function which takes a lambda. So it's not that complicated. So now we have a new binding to post, which will return OK. I'll just run the test again and see if it moves on, if the error moves on to the line 20, I think. It should be. So now it fails on line 20, and we see it's like we don't have any moves, so we should expect some moves here. And at this point, everything was like very immutable. At this point, we probably need to introduce some states or extract game into a variable, convert this into block body. So now we can move game out of roots, and like the whole new backend, it becomes kind of an object, and the game is a field there. So what we want here is something like game, or we want a new instance of the game. So say game move X and Y. The problem, we can make game of var, which is, it will be changeable, but we don't have X and Y. So let's pause this for a second and get X and Y first, which we can do from request. So we can use the same function we've seen called query. So we could do something like that and say it's going to be toInt. And we'll get back an int with question mark, a nullable int, or we can use lenses once again. So I'll use lenses just to show how it works. So it will be a different type of lens. It will lens on the query, and it will be required. So I'll do Y-lens as well. So with lenses, this time we want to use a getter, and well, that's not a getter, it's called extract. And we're extracting from request. What we get back is an int, which is really just X. And we want the same thing for Y. So now we have X and Y, and we can define make move. So because it's all kind of immutable design, what we want is to return a new game, but well, actually a copy, which is going to be all the moves plus a new move with X and Y and some player, where player will be, we can kind of look at all the moves, and we say if there was a move last or now, and there was a player, and if this player is not player X, this can be null or O, then we do X. So the first player who makes the move will be X. That's the idea. Then we return a new game. This game will be updated, and then we do get request in the test here. So we do 3 moves, they're all okay. Then we do this, and we should get back some JSON with moves. So hopefully it fails the way we expect. Yeah, so we get some moves back. It kind of looks reasonable. The players are changing, but it's also quite long. I could have pasted back. And at this point, like another demo for what you can do with lenses. You can use lenses in your tests. So here we can reuse the game lens, and we'll get back a game object. So it's more, the assertion will be using domain objects now, so which it can be nicer. To be fair, it's good to see that your JSON is what you expect it is, but it's also nice in some cases to be able to do these kind of things. Let me run this and make sure that the test passes. Yeah, it did work. And well, following like not TDD approach, should do some refactoring. I didn't do that before. So one thing I would do is extract game as a parameter and call it initial game. So that's basically dependency injection. And you see, we can now construct a new backend by passing game. And the important thing, you don't need really frameworks or anything to do dependency injection. So in tests, we can also now construct a backend with the game which has a winner and see how it works with the backend, try and make a move after there is a winner. And thinking about it, actually, like what we've been doing, we've been like test driving game class from the backend HTTP API, which is a bit weird. In real world, maybe it would be like a good point to kind of stop and say, we probably need to write game tests. Well, I'm not going to do it though, because it's not the point, and we'll pretend we did it and so on. And instead, I'll just type even more code. So what we want, I guess, is also winner here. So there will be a player, nullable player, and it will be find winner. There will be a find winner function, which on construction will figure out if there is already a winner in the game. And if there is a winner, which is not null, then we don't modify game and just return it as it is. And to find winner, we can go through enum values of the player, find a player. Then we need to decide which player is the winner. We can do this by checking if the winning moves for this player are already in the existing moves. Basically just generate all the moves map. And here we say move. It's like X will be the current value in the iteration, and y will be fixed, and that's going to be player. This is like the first row, and we can repeat this with y's. It's not like the nicest code, but I think it will do. Then we can copy all of that and swap x and y. This is going to be it. This is going to be 1, 2, 3, 0. And then there's one diagonal and the opposite diagonal. I hope this is correct. I'll run the test again, but we'll see later because we didn't write any tests for the game. We could have tested this from the backend though as well, but it's not the point. Another thing to mention here is that the game is not this is not entirely thread safe because these callbacks, they're just called by the whatever server you're using. So Httpk, like a minimal library, doesn't impose any threading rules on you. So we ideally should think about it, but I'll skip this for this demo. So all the tests pass, and that's basically the whole backend. And to move on to the front end, I'll first sketch the API. So there will be, similar to backend, will be a new front end function, which will take backend as an HTTP handler. And it will have also some roots. I'll just copy this. It will be, well, just to begin with, let's maybe return body saying some HTML, which is not an HTML, of course. Then if we want to create it, again, we just call a function. And the interesting thing is that here we could have passed, again, just directly reference to the backend as a function, but in theory, we'll be running in different virtual machines. So let's write maybe a backend client here. I'll use HTTP again. And this will be backend client. And we want it also to be a server, so there are two servers. So we cannot have them on the same port, really. So I'll change backend to 1, 2, 3, 4. And there is an interesting question of how we're going to use this backend client in the front end, because it will have to go to the right port all the time. That's kind of tricky. So what we can do, we can say, you can use the client filter, which will wrap the HTTP client, and it will set the base URI to what we tell it to, which will be localhost with the port. So basically we're saying the base URI will be HTTP localhost 1, 2, 3, 4, which is the port of the server. This is why in the front end, we don't even need to know the exact location. So that's another good use of client filters. And that's the sketch of the front end. So to write more, let's write more tests, just to more kind of demo how you would do that. I'll start with the same kind of test, state of an empty game. And once again, just to create the whole thing, don't need any frameworks or anything. We just create things and pass them as a constructor parameter. So this is going to be a front end, private. So to call front end, again, we don't need any test harness. It's really just pass it an object and do an invoke. So we want something like that. We expect OK, and we will get back a response. So I guess we'll be just slash it, it's fine. Then let's use a slightly different approach. So I'll use here an extension for JUnit for approval testing. There is an Httpk module which helps with approval testing, so that's approval test class. What it gives us is that we now can pass an approver into the functions, into test functions. And approver can say, using approver can say, so it's approved response. And if we run it for the first time, I would expect it to fail because we haven't approved anything yet. So let's see how that works. So it does fail, and it says no approved content found. So what happens is that it created this file and resources named after the class and function, and it contains some HTML. And if we're happy with it, we can rename this class to .approved and run the test again. Now the test will pass because we eyeballed the result and we approved. it's also well known as snapshot testing. I think more for front-end people, or like older name is golden master testing. There are like few names, but I think approval, I've been convinced it's the best name. Everyone else is wrong because it's not about snapshots, it's not about gold. It's about humans checking and approving content. Well, here we don't really want some HTML. We obviously need to render something. So let's define an HTML renderer, which I'll use HTML. I'll use handlebars integration with Httpk. Handlebar templates, and I'll use hot reload. We are right now in test folder just because I want to make things simpler. And for HTML renderer, what we can do, we can render an object called GameView. I'll define it as a class GameView, which will represent our game for the front end. And this is like a tagging interface from Httpk. So let me also, well, we will also need to create a handlebars file. That's HBS extension. And I'll define like I pasted from the secret place some HTML. So maybe let's do hello world again. Brighton, exclamation mark, to some good emojis. And if we run this now, hopefully it all works, and we should see that the renderer renders content and it will fail the approval test because it has changed the content of our endpoint. So it fails. Now again, we got two files, one actual, one approved, and if we diff them, we see on the left-hand side, it's what we can expect, so we can check it. Also, it's kind of approval files are good, but it's useful to actually see if it works in the browser. And I think we've been going on for a while without looking at actual browser. So I just switch to the browser, go to localhost. So it actually renders something. That's the ultimate test. Also, to be clear, we didn't have to use like Httpk for frontend, could have used anything else, but just showing that you can do. And then obviously we don't want this as well. We want to render the game. So to do that, we need to get the state of the game. We can do it by just calling backend, passing an object to it. What we get back is a response. And luckily, once again, we can use a game lens, which gives us back a game. So we already have a game basically at this point, and all we want is to convert game to GameView. Hopefully, like, well, I'll cheat a bit and paste more stuff out this stuff just to save time, because it's probably not very interesting. So there will be GameView object, which is kind of a grid of cell views, and the winner is a string. Cell view is similar to move, it's X, Y, and a player. And then there's function which converts game to GameView. Not too interesting. And we also need to update this thing, which is going to be this kind of handlebars thing. So if we look next to each other, the context of this whole handlebars will be game view. So these rows, we iterate over rows. For each row, if there is a player in cell view, then we print it. Otherwise, we print a URL like this with this XY coordinates. And at the end, if there is a winner, which is not null, then we print it. So that's the idea. And well, let's run this. And now we should see like yet another failure in the test, but this time it should be kind of a bit more, let's run tests. This time it should be a bit more reasonable and should show kind of some kind of grid. Now let's look in the browser, it should have refreshed. So yeah, so that's the grid, that looks promising. But if I click this page, this URL doesn't exist, so that's the last thing to do. So I promise should be quick. So now we have two files. Okay, I'll just diff them again to see. Yeah, on the left, that's what we get, the HTML. I'll approve that. And the last test, right, I'll kind of copy it from the backend. And it will be that players take chance. So it will be front end. Let's use get, just because it's easier to do in the browser. And for no particular reason, I'll use paths to pass coordinates, X and Y. Then at the end, we want front end to do get request, and we just approving the response, well, the approver. Let's say approver approved. response. And that should fail because we don't have move function. I expect it to fail on the get request. Let me just switch and like start doing this. So I kind of want move. And because we're passing it, and that's it, it did fail on this line, just checking. So yeah, because we want X and Y, let's do okay. We want to extract X and Y. And this time we're extracting from the path. So there is another helpful function called path. So we can do this. This time we don't need lengths because we don't, well, in this case, we don't validate it. Maybe we should. But right now we're just passing them as a string to the backend. And we're just posting to the backend to the game. And we're saying X is equal X and Y is equal Y. And again, just for the sake of it, we are kind of not checking the response if it failed or not. And we kind of want to render the thing at the end. We don't want just okay. And we could have copied this code from like these two lines, but maybe a bit more HTTP friendly ways to say CR and redirect using location. So browser will go to a different location. But then it will fail here. I'm not going to show it, but it will fail here because this is just a function. It's like not trying to be super clever, but we can have this follow redirects client filter, which will follow redirects. So if we wrap this, our front end into follow redirects filter, then it will do what you would expect. And now it should fail on assert approved, and it will fail in a way that we will see some kind of X and O's in HTML, hopefully. So let's look at here. So we have actual file. Strange that it didn't have any moves. Something went wrong. Not sure, to be honest. Oh yeah, this question mark. Okay. Well, at least tests help with this kind of mistakes. So I would expect it to fail. Yeah, okay, cool. But that's better. We see 2 X's, 1 O. Looks like it should be fine. I'm not going to prove it, but I'll just run it and click in browser just to do the final demo. So let's refresh this. So now the XO, let's make X room. So that's good. If I click on empty lines, it doesn't do anything. And obviously this is a very rough prototype because to start a new game, we need to restart the whole server. It's not ideal. So let's try O and maybe diagonal, which is a bit more tricky. Maybe X, X. Oh, yeah, this worked. And maybe the final one, if I can make it a draw, which we didn't even think about. Maybe we should have printed it's a draw when it's a draw. It can be tricky sometimes. I'm not sure how to make bad enough moves. Kind of delaying where to go. I think I'll succeed. Oh yeah. Oh no, X wins. Okay, so as like that's it basically. So just as a quick overview of the code, we have a main function which kind of creates these things, couple lines. Then we have lenses which are used everywhere and tests and other places. Then we have front end, should have been, of course, in a different file. I'm just doing it for simplicity in one file. So it has front end and some presentation of things. Then we have backend, and we have some domain classes over there. So on the front end, we didn't have anything complex really. It's just a couple endpoints to like show the board and to show moves. And on the backend as well, like kind of getter and setter. And on the test side, we had a couple tests, and I deliberately left lots of symmetry between backend and front-end tests, and we could do the same similar things for the domain objects. And the point here is that you could extract an abstraction out of this and like write the same test, which will go through backend, front-end, or directly to domain. And Httpk kind of helps with that. So that's kind of the whole code, and a couple final slides that everything we've seen is kind of really just an introduction to Httpk. So there are more integrations with HTTP clients and servers, like standard Java clients and servers. There are like other JSON XML libraries, template engines, and serverless platforms, something I didn't even mention. Then approval tests, which like I was mostly doing those. This is actually much more subtle and bigger topic than it seems if you never use them a lot. So yeah, then because of this and like because of the design of Httpk, like simplicity, it makes it easy to do contract tests by recording traffic from external services and so on. Then because everything is a function, just the whole concept makes it easier to do chaos testing. You can record and replay traffic and so on. So if you remember one thing, and I mentioned it in the beginning, but I'll mention again that client and server have the same type signature. And I think most web frameworks and libraries, they overcomplicated things too much. And Httpk, I think it's like one of the nicest, sweetest spots that is so simple and understandable. So it's an HTTP handler request, response, both immutable, and there is like a wrapper around it using a filter. So as the next steps, you can see all this code which I did and like links to other things and the slides. So on this project httpk and GitHub, I'll post it into Zoom. Then there is an official Httpk by example project by Httpk team. There is also obviously Httpk itself. It's open source. You can look at the source code always. And there are like other talks on YouTube. For example, this Talking Kotlin episode by David Denton and Ivan Sanchez, like the authors of Httpk and Talking Kotlin. That's quite nice discussion. And they have other talks, for example, KotlinCon 2018, and this talk test-driven apps with Httpk. There is obviously a website where you can find documentation and so on, and some blog posts. And there is a Httpk channel on Kotlin length Slack, which is quite nice if you need any help. I think usually authors are there and they just help you within a day. So, and this is it. Thank you.
Wow, thank you. Apart from, I don't think I've ever seen anybody write code so fast. That was awesome. If anybody's got any questions, please feel free to pop them in the chat. One thing that I mentioned earlier was that we use Spring Boot quite a bit where I work. What do you see as the advantages over Spring Boot for something like http4k?
Definitely less magical. Well, I don't have a lot of experience with Spring Boot, but I know it's like brings lots of libraries and does a lot of things, and it's configured via properties, which is like, it's like a magic window. You have to know where it's read, where this property is read, what it's going to do. With Httpk, it's quite like more or less directed workflow, so you can like step through in debugger and see what happens. There are a couple. I think maybe there is one example with JSON mappers or something, but in general, it's quite functional. So there is no secret property you have to set. So yeah, that's the advantage. Spring Boot, I think it does way more things than HTTPK, but then it's more complex. When something goes wrong, like it might not be obvious what it is. And it's just the other big difference is that Spring Boot way heavier. It has lots of dependencies. If you actually like look at, you can integrate to like download all your dependencies default. If you just look what's there, you might be surprised. And it uses reflection, which is not so great for cloud native things and so on. So with HTTPK, well, lenses, they kind of do, but you basically you can use lenses and not use reflection. So this will allow you to run, for example, your application through a Graal more easily with fewer problems. So it's very small footprint. HTTPK core module is like minimal. It doesn't depend on anything. So yeah, it's more like, I think the other conceptual difference that HTTPK more like a constructor blocks like Lego, and Spring Boot is like this big thing which you have to configure. That's my conceptual understanding. So you can like choose like the big thing if you like know it well, and that's your preference. Like nothing's wrong with that.
Awesome. Nice one. What about the kind of coroutine support and things like that for HTTP4K?
Yeah, it's the most famous question for HTTP4K. I think they answered it many times, and I think the summary is that conceptually they were not against it, but the authors, they were very pragmatic about it, and they did only the things that were necessary. And they found that in the real world, most projects don't need this, like the edge of like saving memory and so on threads, because like for various reasons, basically you're not Google. Most companies, you shouldn't fool yourself. Make your thing work first, and then maybe optimize it. And maybe if you optimize and measure, you'll find the actual bottlenecks are elsewhere, and so on. So that was one point of view. They just never had the real need. The other problem was that Kotlin didn't fully support it. So they tried it and kept trying for years. And only recently, I think Kotlin, maybe in 1.6, it will allow to inherit from suspend functions. So previously, this part was not working. As you have seen, I showed that, for example, filter or HTTP handler is just a function. So if you want it to be coroutine friendly, it has to have suspend keyword on it, but you would not be able to extend it. So they just fixed it in Kotlin. So basically, Kotlin didn't support this model. Coroutines were never finished in some way, but now they're kind of a bit closer. So maybe it will come at some point.